So to those who did not make it for the elimination round 1, you can still register for elimination rounds 2, 3, and 4. So again, congratulations to Gerald Adorna, Joshua Emmanuel Hugo, Mansur Aguas, Clarence Duran, Eugene Rosete, John Reynan Bernella, and Kyle Sherwin Balala. So you don't need to, if you did register to the other 3 elimination rounds, since you are all in to the semifinalists, you don't have to do the other 3 rounds. Okay, congratulations again. So let's proceed to our problems. Let me share my screen to you first. Okay, so let me test if I can work on my. Okay, it's working. Okay, so the first problem is based on data from the easy round. First problem E1, based on data from Statistical Agency of Singapore, the probability that a newborn baby will be a boy is roughly 0.651. In the next 6 births, what is the probability that at least 3 are girls? The final answer must be in 3 decimals. So the first requirement is to find the probability of a newborn baby girl. Of a newborn baby is a girl. So this is pretty easy. So if you have the probability of getting a boy at 0.651, right? So since this is a binomial distribution, simply subtract 1 from the probability of a boy and you will get the answer for letter A, which is 0.349. Right? That's pretty easy. Okay, so the next question is find the probability that at least 3 are girls from the next 6 births. So let me first introduce some of and clear this. So some of the formulas. So since the probability of success is the variable p, which is the probability of getting a girl, which we already computed at 3.49. So therefore, the probability of failure is q, which is the probability of getting a newborn baby as a boy, which is 0.651 given. So the formula we will use is this long formula here. So that's a binomial distribution. And it says f of x is px equals to x and x px q to the n minus x, which is equivalent to n factorial over x factorial quantity n minus x factorial p to the x q to the n minus x. And if you expand this is actually equal to the p plus q to the n, which is the summation of this combination px p to the x q n minus x from x equals 0 to n. So if you say if we have p at least 3 girls in 6 births, so our x capital X should be greater than 3, right? So for at least, so from the next 6 births, so 3 greater than or equal to 3. So we will gonna add p equals x equals 3, and then p equals x equals 4, p equals x equals 5, and p equals x equals 6, right? So clear that. And then this is how you're gonna do it. So it's a combination 6 to 3, and then your probability of success is 0.349 raised to the third power, and then and the probability of failure is 0.651. So total in 6 births minus the we're looking at least 3, so minus 3, and then all the combination 6 is to 4, and then 6 to 5, and then up to 6 is to 6. So this is the formula for getting the combination 6, uh, 3, and then 6 birds we get 4, 6 birds we get 5, and 6 birds we get all 6. So when you calculate this, you will get the sum of 0.351. So the answer for at least 3 girls in 6 birds would be 0.351 here. Okay, so let's go to question number 2. Easy round number 2. I noticed a lot of the contestants were not able to solve this. If you remember my Singapore session with Math Agility Live, we actually solved this one. So if you watch that, you're lucky you will be able to solve this problem. So uh, let's read the problem. So Megan and Andrew had some SMS texts in their mobile accounts. So instead of SMS text, I think I used money from that problem. So I just tweaked it a little, and but the variables are the same. I mean the numbers are the same. I just changed the instead of using money, I used SMS text. Okay, so Andrew sent 3/5 as many text messages as Megan and was left with 4 fewer SMS texts than the text message she sent. So Megan had 2/5 as many texts left as Andrew. The difference between the numbers of texts they had in the end was 21. So how many SMS texts did Megan and Andrew have at first? So we're gonna compute Megan's SMS text initially or originally, and also Andrew's. So this is how I will do it. It's again the table method I'm using whenever I have like algebraic problem like this. So let's say Megan has X original number of SMS and Andrew has Y. So it says in the problem that Megan sent 3/5 of what's that? 3/5 as many texts as Megan. So if we say Andrew sent Z number of SMS sent, so 3/5 of Z would be the number of SMS sent by Megan. So 3/5 Z, as you can see from the table here, right? Okay, so now if so the SMS left is definitely we just need to take the difference of X minus 3/5 of Z. So that's the number of SMS left for Megan. And then for Andrew, that's also Y minus Z. Okay. So the first equation we can form is uh, Andrew sent 3/5 as many text messages as Megan and was left with 4 fewer SMS texts than the text messages she sent. So X minus 3/5 Z would be equal to 3/5 Z minus 4, right? So we will name it as equation number 1. And then the second equation we can form is from the statement when Megan had 2/5 as many texts left as Andrew. So Andrew had Y minus Z. So 2/5 of what is left from Megan is 2/5 of the quantity X minus 3/5 of Z. So that's equation 2. And then we can also form the third equation since we have 3 unknowns. So we should form 3 equations. And the third equation is the difference between the number of texts they had in the end is 21. So X minus 3/5 Z, quantity X minus 3/5 Z minus 2/5 quantity X minus 3/5 Z is equals to 21. So when we try to simplify this, we will get 3/5 of X minus 9/25 of Z is equal to 21. So that's our equation 3 here, right? If you can see, so that's equation 3. And then now from equation 1, we can solve x in terms of the variable c. So we have here in equation 4, x equals 6/5 of z minus 4, right? So this one here. And then let's substitute this equation 4 into equation 3. So we will eliminate the variable x, right? Uh, so we will be able to solve the variable c in this case. So if we try to just move it a little. So if we try to substitute our value of x, so this value here, we put in the variable x here, right? So this becomes 6/5 z minus 4, and then minus 9/25 of z equals 21. So simplifying it, we will be able to solve our z, which is 65. So that's the number of SMS sent by Andrew, right? So if we go back to our table, so z is the number of SMS sent by Andrew here, right? Okay, so let's go back. So now let's substitute the value of z to equation 4. So this is equation 4 here. Equation 4 is this one here. And we will substitute the value of z. So we will get the value of x. So when we do that, we will get 74. So x is actually what? X is the original number of SMS sent by the number of original number of SMS by Megan. So that's 74, right? And now let's substitute the value of z and x to equation 2. So this is what I'm doing in this part here. So the original equation is y minus c. And so we have the value z and x. So definitely we can solve the value of y, right? And based on their computation, y is equal to 79. So therefore, Andrew has 79 SMS in his account originally. And Megan has how many? 74 originally here. And this one here. Okay. So if you have any questions, please write it down in the comment section of our Facebook account, Twitter, and Instagram account. Okay, so let's move to uh, easy problem number 3. So this is a statistics problem. So let me read it. So the National Health Research Center has recently released a study on a medical test for COVID-19. In the table shown below, COVID-19 is labeled as disease X and has outcomes positive and negative, including their probability. So given this table, we so there's a statement here below. If a person goes for a test and get a positive result, what is the probability that the person has COVID-19 disease? So it is required that their answer to be in 3 decimals here. And then there's a follow-up question. So now if a person goes to a test and get a negative result, what is the probability that the person has not infected by COVID-19 disease? Again, it should be in 3 decimals. So we will use the formula for conditional probability given a positive. So here, given that the person has tested positive with a positive result, and then the patient says we have a COVID-19 disease. So there's a probability of plus intersection of x divided by the probability of getting plus, right? So if you look at the table, so the intersection of plus and x would be 0.008 here. And then the probability of positive would be the sum of 0.008 and 0.098, sorry. So that's why we add, if you look at the denominator of our conditional probability, we added 0.008 plus 0.098, and you will get an answer of 0.005, 0.075, sorry. And then for the next question, so in case the patient got tested with a negative result and the patient has no COVID disease, so again, our conditional probability, so first is it should be negative and then no COVID disease. So if you look again at our table, so the intersection of negative and no disease is 0.098. This one here. Sorry, 0.895. And then the sum of we're getting the sum of probability of negative, so it should be 0.002 plus again the 0.895, right? So if we go back, so 0.895 divided by 0.002 plus 0.895, we will get 0.998. So that's pretty easy if you know conditional probability. Okay, so let's move to question number 4. So this is a combination of trigonometry and geometry, and what else we can, yeah, trigonometry and geometry. So the problem is you have three circles with radii tangent squared x, secant squared x, and 1.0 that are externally tangent. What is the area of the triangle formed by joining their centers? So it is required that we have to draw. So this is the correct drawing. We would assume they have different sizes of radius for tangent squared x, secant squared x, and 1. So if you got this drawing, you got zero point 0.5 points here. And then for letter B, we are asked to find the area of the triangle. So this triangle in the middle, the blue one here. This here, let me change the color. So this red one here, right? So, okay, let's move to the next page. So we will use the heroes formula or herons. So they call it several terms for this formula, but we need to identify first the A, which is tangent squared and secant squared. If you look at the figure, that is the top part of the triangle. And then B is 1 plus secant squared. So that's the right part of the triangle. And then 1 plus tangent squared, which is C, the left part of the triangle. Okay. And then we need to take S equals 1 half of A plus B plus C. So that's part of the formula of hero. So that is 1 half tangent squared secant squared plus 1 plus secant squared x plus 1 plus tangent squared x. So if you simplify this, you would get 2 secant. Okay, let me just 2 secant squared x here, right? And the formula for area is k equals the square root of s minus a, s minus b times s minus c. So simply substitute this. So we get s, which is this, and then s minus a, so 2 secant squared x minus tangent squared and secant squared. So I distributed the negative part. So this becomes negative here instead of positive here. And then 2 secant squared minus b. So 1 plus secant squared. So again, this time I did not distribute it right away. I kept it in this form, 1 plus secant squared, and then 2 secant squared minus, uh, since 1 plus tangent squared is also secant squared, so I write it directly here. So of course, this would become just secant squared. And then what else? So again, here it should be 1, right? So this is that part, and then the negative one here. And then, so I also, this would become 1 if you combine all the second squared minus tangent squared. So second squared minus tangent squared is basically equal to 1 because of the identity 1 plus tangent squared x equals second squared x, if you remember your trigonometry, right? So if you have second squared x minus tangent squared x, so this is equal to 1. So that's what we did. That's what I did here in this part. So I have 1. And then what happened here? So second squared minus 1 is tangent, right? And then this second, so this is the tangent part here. And then this second squared, I added to the second squared in front. I multiplied it. So you have to the fourth power of second, which is now here in this front, right? So let me just clear it. And then you have the tangent squared, which comes from this um, identity here. So if you get the square root, so square root of 2, so second square root of x, tangent of x. So this would be your area. All right. Okay, so okay. If you have any question, please write it down on our comment section below of our Facebook page, Instagram, and Twitter account. So let's move to question number 5. So this is discrete mathematics. So we are asked to verify the proposition A. So this symbol is called the disjunction. And this is similar to or union in set theory. So, and then if you have the inverted B, this is conjunction. And this is equivalent to set theory as and intersection. Okay, so if you see now this one here, this is negation. So it means not, right, in set theory. Okay, so what is a tautology? It means that columns you will get after forming your truth table should give you all truth or T, right? So let's try to do it. So the first variable is A. So we will form our truth table T, T, F, and F. And then for B, so we do it TF and TF. So when we combine A and B, so it means conjunction of A and B. So we're just like multiplying. If you say T is 1 and F is 0, right? So it will only have 1 when both are true or both are 1, right? So you will get here T, the rest would be 0 or false, right? Now, if we negate it, so negating it would be the inverse of this column. So true would become F and F would become true. So F, T, T, and T here, right? Now, so after the negation, we need to get this A disjunction of this whole negation that we have, right? On this column. So if A is true and or or would be like adding, right? It's union. So if you have a 1, at least one or true in either column, then you will have right away a true as your answer. So T and F would be true. So let me clear it. T and F would be true. T and T, of course, would also be true. F and T would also be true. F and T would also be true, right? So this is a tautology because you get all through in the last column, right? So, okay, so let's move now to the average question. So, okay, again, this question was given in our math agility challenge. We posted it. So I hope everyone gets this as well. Okay, so you will have 2 points if you answered both the requirements to get the first and last digit and the price of one chicken. So let's read first the problem. Just give me a second. So the National Historical Institute of the Philippines recently discovered a lost recipe in the old house of Juan Luna. In a small piece of paper was the note 72 Polo colon and then underscore 67.9 underscore reales. Polo is the Spanish word for chicken, and reales is the money or currency used during the Spanish period in the Philippines. This note, according to the Institute, is the total price of the 72 chickens during that era. However, the first and last digits were already faded in the note. So this is the first and the last digit referred to the problem as faded in that note. So we are asked to find the two digits and the price of one chicken during that era. So this is a divisibility problem. Let me move. Let me scroll it up. So let's try to find a process and how to solve this. So first is if if 679 is divisible by 72, which is the total number of polo or the chicken, so then it would be divisible by 8 and 9, right? So if it's divisible by 8, the number 79 must be divisible by 8. Okay, so if we'll do a trial and error from 0 to 9, so we're trying to see if it's 790, 791, 792, up to 799, and try to divide it by 8, you would find out that 792 would be the answer here. So it means there is no remainder. It will be divisible without remainder by the number 8. So our answer for the last faded digit should be 2. Okay. So now that we know the last digit, let's find out what is the first faded digit. So we already use 8. This is already checked. So let's try to use 9. So it should still be divisible by 9. And the rule of divisibility of 9 is that when you add the digits 6 plus 7 plus 9 plus 2 equals 24, and then the last but the first faded digit, it should be divisible by 9. So if you add them together and you get 24, and the nearest number to 24 that is divisible by 9 is 27, right? So if you subtract it, 3. So meaning 3 is the missing digit in the first faded digit. So 27 minus 4 is 3. So our digits should be 36792. So again, putting back the decimal point in between 7 and 9. So 367.92. And if you divide it by 72, you will get 5.11 reales per chicken. Okay. Okay, let's clear this. Let's move to average question number 2. So let me just scroll it up. So in case you have questions or comments or you don't agree with my solution, please type it in the comment section, okay? So for average question number 2, a first sphere has a radius of x sub 1. About this sphere, circumscribe a regular tetrahedron. About this tetrahedron, circumscribe a second sphere with radius x sub 2. And then about the second sphere, circumscribe a cube. And about this cube, circumscribe a third sphere with radius x sub 3. So the requirement is find the sum of all the three radii and its ratios. And if you read letter A in our points, you would get a point 5 points if you draw the diagram of this problem. So Okay, let's move. I'll be scrolling it up. So this is the best way I can draw this. So this is the first sphere, and then this is the tetrahedron, and then this is the second sphere, and this is the cube, and the third sphere is here. Okay, so if you label it x1, and then this would be if this is x1, and this would be x2, and let's say this is x3 here. Okay, so those are the radii of the three spheres. So you would get 0.5 points already without even computing. Okay, so let's move. So in the tetrahedron, so an altitude is one leg of a right triangle whose hypotenuse is an edge, right? So the edge, so I draw the tetrahedron here. The edge is A, has a length of A, which is this. And then the height of tetrahedron is capital H. And then the slant height is small h here, right? So let's try to compute first the slant height. So let's look at the face of the tetrahedron, meaning I took this view here and draw it here as our face of the tetrahedron, okay? So, of course, the face of a tetrahedron is equilateral triangle, and it's also equiangular. So each of the angle of the triangle would be 60 degrees, right? So my h is this h here, the height. So let's take, we are solving h, so h over a, or h equals a sine 60 degrees, and sine 60 degrees is actually square root of 2, right here. Okay, so next is, now let's compute the height of the tetrahedron h. So now that we have h, small h, let's compute capital H. So a tetrahedron actually has this you call property here. So the x, which is the leg, so this, now let's look at the base of the tetrahedron. So this green line here is actually this green line here. And one of the properties of a tetrahedron is that the altitude of the tetrahedron is 2/3 of the slant height of the face of the tetrahedron. So we already computed the height, the slant height of the face of tetrahedron, which is square root of 3 over 2a. So we'll just input 2/3 here to get x, which is the other, what do you call this? The other leg. So this is x, this is h. So that this is one of the leg of this triangle that we form. So this is actually equal to square root of 3 over 3a, right? 2/3 of the slant height, which is this. And then, so since we know this and x and h, we can solve, this is actually your edge, right? Edge of your tetrahedron, which is a. So we can solve h by Pythagorean theorem. So let me clear this and let's move the screen up. So by Pythagorean theorem, we have x squared plus h squared equals a squared. So simply move x squared to the right hand side. So, and substitute its values. Earlier we computed it as square root of 3 over 3a. So we will get the height of the tetrahedron as square root of 6 over 3 times a. Okay, so now we have this value for h. Okay, the next thing is we're gonna compute the lengths, the total lengths of um the diameter, not diameter, but radius of the this the first sphere and the second sphere, which is x1. That's the first. Excuse me. That's the radius of the first sphere, and x2, which is the radius of the second sphere, and that is equivalent to what we already computed here, which is square root of 6 over 3, right? Because the height of the tetrahedron is actually uh, the alt the altitude or the height of the tetrahedron is equal to x1 and x2, right? Okay, second sphere and the first sphere. So now, if you look at the center of the tetrahedron, look at this figure here. We have an x, and our x1 would be here because that's the smaller. This is the smaller sphere. We have x1 as its radius, and x2 on this case would be the hypotenuse of the blue triangle inside the tetrahedron, right? So we can compute. So the legs are x1, right? And we know that x1 is square root of 3 over 3, right? So and we will can see that the x sub 2 squared minus x sub 1 is equal to, which is again the Pythagorean theorem, right? This part here, this is also Pythagorean theorem. X sub 2 is actually your hypotenuse minus one of the leg, which is x1, and then equal to x, right? So this would be equation 2. And then let us divide equation 2 by equation 1. So equation 1 is x plus 1. If we expand the quadratic equation, which is the numerator, so let me just scroll it up. We can expand it as x sub 2 minus x sub 1, quantity x sub 2 plus x sub 1. So we can see that this cancels out. This and this, right? And we have x sub 2 minus x sub 1 equal to square root of 6 over 6, which is our equation 3. Now, let's adding equation 1 and equation 3. We will be able to solve x sub 2, which is the radius of sphere number 2. And then solving for x sub 1 from equation 1, what's equation 1 again? Here, x plus 1 plus x sub 2 equals square root of 6a. So substitute the value of x sub 2, which is this value here, and we will get x sub 1 equals square root of 6 over 12a. Okay, so now we have the ratio for x sub 1 to x sub 2, so which is this. So x sub 1 is to x sub 2 is equal to square root of 6 over 12a is to square root of 6 over 4a. So we can cancel out a and simplify it into 1 is to 3. Okay, so we're done with the first part. So let's solve now for x sub 3. So let's look at the cube. So let's refer to the left, this part here, and let's say the edge of the cube is b. So the second sphere, which is inside the cube, would have b over 2 here because it's half of the length of the edge of the cube, right? And if we include the third sphere, so this is the third sphere, uh, we can compute actually the diagonal of the face of the cube, which is the square root of 2b. This is simply getting the hypotenuse of the sides of the triangle. So this is b over 2 and b over 2. So we can get square root of 2b, right? And then we know that this is b over 2, half of the length of the cube, and then x over x sub 3 is the radius of the sphere. Of course, uh, the drawing is not that accurate, but this edge of the cube would touch the 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 sphere, so meaning it would be equal to from the center to that intersection of the cube and the sphere to the radius of to the sphere number 3, right, which is x sub 3. So of course, again, we can use Pythagorean theorem. So in this case, we're using Pythagorean theorem now 3 times or maybe more. So x sub 3 is just the square root of b half squared plus the half of the diagonal. So we know that this is the diagonal, the whole thing here, but on below it's only half of it. That's why we divide it by 2. So we will be able to solve square root of 3 of b over 2. So we will be able to get the ratio of x sub 2 to x sub 3, which is x sub 2 is to x sub 3 is 1 to square root of 3. So if we combine now the ratio of x1, x2, and x3, so let's try to link those two ratios that we have, and the only connection or the only common to the two ratios that we form is x sub 2. So this is what I did. So x sub 2 over x sub 3 is over square root of 3. So this is how we're going to form this ratio into an equation instead of a ratio form, right? So this is what I did here. And I simply substitute this in the ratio of x sub 1 to x sub 2 here. So instead of x sub 2, I substitute this value I got from the other ratio and get the ratio of x sub 1 to x sub 3 is 2 3 square root of 3. So we can therefore conclude that one x sub 1 is to x sub 2 is x sub 3. The ratios of these three radius of the sphere is 1 is to 3 is to 3 square root of 3. And then how do we get the sum of this? So again, we will use some representation because these are ratios. So let's say x1 is equal to x sub 2 is equal to 3x, and x sub 3 is equal to 3x squared of 3. Then the sum would be x plus 3x plus 3 squared of 3x. So total is 4x plus 3x squared of 3. Okay. All right. So let's move to the third. So again, this is statistics. So these are Korean names and these are not Filipino names. So Kishai, I think, is how they read this. So Kishai wishes to test the following claim H sub A. So that's the alternative hypothesis at the significance level of alpha of equals to 0.01. So null hypothesis is that mu1 is equal to mu2, the equal mean. And the other is that mu1 is greater than mu2. So Eugene and Kishai believe that both populations are normally distributed and the standard deviations for either is not known. So let's assume that the variances of the two populations are not equal. Eugene obtains the following two samples of data. So we got the sample 1 data here and the sample 2 data. Okay. So what I will do, what I did actually to make life easier, I inputted this in the Excel form, right? So it's easier to compute for uh, the means and the standard deviation and as well as the p-value. So let me just stop sharing this. Okay. So anyway, I would not show this. So anyway, so when you use your Excel sheet, so it will also automatically count the number of samples, so which is 90 for the first sample, and sample mean. So another word for mean is average. So simply total the number of samples and divided by the data count, which is 90 here, and you would get 107.10, right? And then let's compute the sample standard deviation. So this means for each of the sample, we subtract the mean of 107.2 and then get the square of it and then add them together. So example, so if you have a sample of 100, you subtract 107.10, right? And you square it. And then, for example, the next sample is 99. Again, you subtract the sample mean of 107.10. And then, example, this is 70. Again, subtract it by 710 squared. And then, whatever you got here, total it. So that's what this equation means here in the numerator of summation from I to n of x sub I minus x1 bar, which is the mean, squared, right? So that's how you do it manually. But if you know Excel, that will your life will be easier computing this. Okay, so once you did that, you'll get 32.65. So similar to sample 2. So we counted the number of sample, which is 86. And then we got the sample mean, which is sum of all the numbers divided by the data count, which is again 86. We would get 129.57. And then let's get the sample standard deviation. So this is 51.62. Okay, so for the first question, it asks us to find the test statistic. So this is simply a formula. Since this is a t-distribution, this would be mean of sample 1 minus mean of sample 2 divided by the square root of the standard deviation squared of sample 1 over n1, which is the data count of n1, plus sample standard deviation of x2 squared divided by the data count. So, and you would get negative 3.4335 as your test statistics. Okay. So now how to compute the p-value. If you have two samples, you have to check first the degrees of freedom for sample 1. So sample 1 has 89 and the degrees of freedom of sample 2 is 85. So since we're using right-tailed and we want a conservative estimate, we should pick the smaller value of degrees of freedom. So we use the F2 as 85, right? So again, if you're in Excel, we can input this formula. So just press equals and then 1 minus t dist. So this will if you type t dot dist, it will automatically appear in the screen of your Excel sheet. And then simply input your test statistics. So this is your test statistics, the first, and then comma, your degree of freedom 85, and you should put through, meaning it's what do you call this? Cumulative. So meaning it adds up, right? When you say true, it is cumulative. So the Excel would give you this value of your p value as 0.9995. So okay. Okay, if you are also not using any Excel, you can use still the table for t distribution. But I highly recommend that you use technology this time, like your scientific calculator or your Excel. Okay, because this is a competition, so you need to be quicker or faster in solving this kind of problem. So in question number 3, the question is just simply State the numerical relationship of the p-value and alpha. Since our p-value is higher than the alpha of 0.01, right? So this should be the answer. P-value is greater than alpha. And then for question number 4, since p-value is greater than alpha, we fail to reject the null, right? And then for question number 5, the final conclusion is letter D. There is not sufficient sample evidence to support the claim that the first population mean is greater than the second population mean, right? So it means the null are, what's the basis of our null, that they are equal, right? And there's no difference between the sample means of those two data that we got. Okay, so if you have any question, please write it down, or if I miss something to elaborate on this solution, please also write it down, okay, in our comment section. Okay, so let's move to question number 4. This is physics, and the question is about circuit. We will actually need to solve the current in R2. So here, what's the current here? And the voltage drop in R3 here. The voltage just drop here. So it's specified that we need to use Kirchhoff's rules. Okay, so let's try to scroll it up. So this is the solution. Of course, first is we need to label the nodes, but it's up to you if you do this. Sometimes student would go right away and doing the loop assumption for current, how the current will flow, since we have two loops here, right? So it's also good that we name the junctions or the nodes. So I name it A, B, C, D, E, and F. So A here, B, C, D, E, and F. Okay. And then, so I1 is the current in branch FABC. So FABC is this one. So that's the current. And I assume the direction to be this. And in the second, the current in branch EF, branch CDEF. So I assume the current to be flowing on this direction, which is I sub 2, right? And then therefore on the in branch C, I did I1 minus I2 here in branch C. Okay. So okay, so this is what it will look like when after assuming the direction of current. So I1 would flow counterclockwise, and also I did I2 for counterclockwise, right? So let's do loop 1. So negative B, so you start from here. So this means negative, positive, so negative B1. And then you go to the loop R1 times I1, which is your current, and then plus I1 minus I2, which is the current flowing here, times the resistance 2, right? And that should be equal to 0. So once you substitute, you would form an equation which is I1 is equal to 30 plus 15 I2 over 35. That's equation 1. And then now let's go to loop 2. So loop 2 is I started again with the voltage. So since I start with the plus, so I put positive V2 minus. So since my direction is counter to the first assumption that we had for I1 and I2, so I should put negative here instead of positive. So in loop 1, we said it's the direction is up, and we said that's positive. And now for I2, I said this should be down, so it should be negative in this case, right? So I put negative here. And then times R2, of course, and then I2 plus I2 times R3, sorry. And then that should be equal to 0. And then let's substitute everything. We will get equation 2 as negative 15 I1 plus 65 I2 is equal to negative 20. So if we substitute equation 1 to equation 2 here, uh, we will be able to solve that I2 would be negative 0.122A. So meaning our assumption for the direction of I2 is not counterclockwise but clockwise, right? So that's what it means by the negative here. So now we can solve for I1, right? Simply substituting this value to equation 1 and we get 0.05 amperes. So the current in R2, which is, we know that it's I1 minus I2. So I1, we say is 0.805 minus this. So we get the answer for the current in R2 as 0.927 ampere. Then the voltage drop at R3. So we know that current in R3, the current is I2, right? This is that one. And the resistance is 50, so we get negative 6.1 volts as the voltage drop there. Okay, so that's it. So let's move to the next problem. Again, this is a physics problem relating to electric fields, right? Okay, yeah. So let's read it. At the Agility Labs, Dr. Minori is doing an experiment. His observations and measurements are recorded that a proton, neutron, and electron are in a uniform electric field of 50 newtons per coulomb that is caused by two large charged plates that are 40 centimeters apart. The particles are far enough apart that they don't interact with each other. They are released from rest equidistant from each plate. So for the first question, what is the magnitude of the net force acting on each particle? So since we have the charge, we have the elements, the different elements, and we know the electric field force, yes, which is 15 newtons per coulomb. So simply multiply the charge of proton times this one here times the electric field given. So we'd get 8.0 times 10 to the negative 18. Now for electron, which has the same charge for proton. So this would get again at 8.0 times 10 to the negative 18 Newton. And then from neutron, since it's not charged, so F would be 0 Newton. Now for the second question, the question is, we're taking the acceleration of these elements. So again, we know A equals F over M, so force over its mass. Again, we know the masses of these three elements or particles. So whatever we got from A, we divide it by their mass. So we'll get the acceleration here. For proton, that's 4.79 times 10 to the 9th power meter per second squared. And then for electron, it's 8.78 times 10 to the 12 meter per second squared. And then for neutron, since there's no force, so the acceleration would be 0, right? Okay, so the third question should be about work. So how much work will be done on the particle when it collides with one of the charged plates? So let's compute for letter C. So we know the equation W is force times distance, right, for work, or since force is actually charge times the electric field times the distance. So in between plates of 40 centimeters, that is 20 centimeters, right? 20 centimeters, right? So 20 centimeters is equal to 0.2 meters, right? So this is what we used in this formula here. So simply multiplying the charge, the electric field, and then the distance, we will get work as 1.6 times 10 to the negative 18 joules for proton, similar to electron, and then 0 for neutron. Now let's go to letter D. What's the question for letter D? So what is the speed of each particle when it strikes the plate? So now we're looking for velocity. So if you know the one of the five kinematic equations, so B F is equal excuse me, square root of 2ax. So a is your acceleration, x is your position, x sub is your initial position. So if the particles are midway between the 40 centimeter plate, they will travel 0.20 meters or 20 centimeters, right? In between. Okay, let me just scroll this up. Sorry. So let's compute their velocities for proton. That's 2 times the acceleration times the difference of distance of zero point 0.2. You would get 4.38 times 10 to the fourth. And then for electron, 1.87. And then neutron is 0 again because of zero acceleration, right? And then for the last requirement, what's letter E? Letter E or number 5, how long does it take to reach the plate? So we're gonna solve for time. So again, from the kinematic equations, T is final velocity divided by acceleration, right? So since our initial velocity is 0, it's at rest. So we have only the final velocity which we computed in letter number 4 or letter D. So per proton, that's 4.48 divided by acceleration, which we already also solved. So we would get 9.14 times 10 to the negative 6 seconds. And then for electron, that's 2.13 times 10 to the negative 7 seconds. And then, of course, for neutron, it will not hit the plate since it never accelerates or it will not move. Okay. All right. So let's move again. Okay. So we're done with average questions. So let's move to the difficult questions. So we also have 5 problems for the difficult uh, round. But this time, each problem would have 4 points each, right? So I think P1 is also one of the problems given last year. So, not yet, not this one, sorry. This is a new problem. So, let's read the problem. Consider the cubic function g of x below. So, we need to find the intervals on which g is increasing and decreasing. Number 2 is we need to find the local minimum and maximum values of g. And then we need to find the inflection. Fourth is where G is concave up. And fifth is where G is concave down. Okay? So the easiest way to solve for number 1 is to graph it, right? So that's what I did here. So we can easily see that it's increasing from negative infinity. So it starts from here up to the peak, which is at negative 6. So I got the first notation here. And then where else it is increasing? Of course, from 3 at the bottom part here going to positive infinity here, right? So in interval notation, this is how it will look like. So parenthesis negative infinity, comma negative 6, union of parenthesis 3, comma infinity. And then where it is this decreasing, so again from the peak of negative 6 up to 3. So the decreasing interval is parenthesis negative 6 comma 3 close parenthesis, right? So for the next question is we need to find the local minimum and local maximum. Okay, so since the slope on the left of 3 is negative, so if we go back to here, slope is negative here, right? And while the slope is positive here, uh, there should be a local minimum at 3. So let's substitute 3 in the original cubic function g of 3. You would get negative 3.73 as 373 as your local minimum. Again, if you look at the graph, 6 on the left, the slope is positive, and on the right, it's negative. So there must be a local maximum at that peak. So if we go down and substitute this in our function, we would get 1085 as our local maximum. Okay. All right. So let's go to question number 3. And question number 3 is I think we need to solve for the inflection. So we need to get the derivative, the first and the second derivative of our function. So the second derivative says this is equal to 24 plus 36, right? Okay. And let's equate this to 0. So equating the second derivative to 0 and then solve for x coordinate to get the inflection point. So this is our second derivative and then we equate it to 0 and we get negative 1.5, right? As our x coordinate of the inflection. So to solve for the y coordinate, of course, we need to substitute it in the original equation, our cubic function, and you will get 356. So the inflection point should be at negative 1.5 comma 356. Okay. Okay, for number 4, um, the easiest thing to do to find the concave up or down of the curve is to plot the first derivative. So this is what I did. I plotted here. So this is how the graph looks like. It's a parabola, right? So if we again refer to the graph, so from the bottom of this parabola or the center of this parabola or the vertex of this parabola is at negative 1.5 comma negative 2.43. So since we're only referring to the x part, x of the coordinate, so from negative, it's concave up from here up to here, right? So negative 1.5 to infinity, and then it's concave down here. So from negative infinity to negative 1.5. Okay. So this goes to infinity in terms of um, your x, and this goes to negative infinity in on the other direction, right? In terms of x. Okay. That's it. So if you answer all of the 5 questions, you would get 4 points right away. So that's I think this question for the difficult round is still easy. You just be careful where to substitute your values, and that's it. Okay, so let's go to question D2. Okay, this is the question actually that was included in last year's finals, maybe on one of those. We had actually 9 monthly competitions, so this was given already. I just changed a little bit, but the function is still the same. So if you bought the ebook, you would probably had gone across this question. Okay, so Let's read the question. So the jet setter friends, Maine, Alden, and Prince were not sure how to pack all the branded products they bought from the Prada store in Paris. The policy in the airline clearly stated that all baggage must be in box shape with a sum of length, width, and height not exceeding the biquadratic of the function f of x. The function is the congruence equation, which is this f of x 26x to the fourth minus 31x cubed plus 46x squared minus 76x plus 57 is identical to 0 mod 8. Okay. The question is, what are the dimension and volume if the three friends decided on a square box based box to package the product products while achieving the greatest volume under these conditions. Okay, so the first thing we need to do is to solve the congruence equation of f of x modulo 8 and to reduce the coefficient. So let's go to the coefficient one by one and taking the modulo 8 of that. So modulo 8 so means the nearest to 26 is 24, right? So 8 times 3 is 24. And if you subtract it to 26, you would get a remainder of 2. So the 2 there is actually your remainder. And then same thing with 8, 31. So 24 and 31 has a difference of 7. So that's the remainder again. For 46, 8 times 5 is 40. So the difference would be 6. And then 8 times 9 is 72. So 76 minus 72, the difference is 4, right? So you're simply when getting the modulo, simply you're stating the remainder closest to the uh whatever modulo number you're computing to. Okay. So next is we have the reduced form, which is this, and we can still simplify actually the sec this and this. So I again take the modulo of that. So negative mod 7 module here 7 modulo 8 would give us a negative 1, and then for 6 we get negative 2, right? So I rewrite our function as t of x instead of s of x. That's what we get here. And then now we will need to test t of x by substituting the values negative 3, negative 2 up to 4, whichever will give us uh, a modulo of modulo 8, which is 0. And based on this testing, this is the only at 160, or when this is equal to 3, our x is 3, would get 160, and that's will have exactly divisible to 8 modulo 8 0. Okay, so therefore the value of f of x modulo 8 is 3, which is this. And for question number 2, we need to find the volume. So the volume of the box shaped baggage is length times width times height with a square. Since this is a square box, so the base should be a square. So length and width would be the same. So that's x times y. So this would be equation 1. Okay, let me scroll up. Again, it says here the perimeter should not exceed the biquadratic of the function f of x. So this means we need to take the fourth power of the value of f of x modulo 8, which is 3, raised to the fourth power. So length plus width plus height, which is the perimeter, raised to the fourth power. Okay. And we get y as equation to as y equals 81 minus 2x here. So we will be able to compute the volume, which is this, given equation 1 and 2. So x squared. So everything now is in terms of x, right? So v is 81x squared minus 2x cubed. Okay, so let's get the first derivative. So since we're maximizing it, right? So with respect to x, let's get the derivative of v with respect to x, and we will get 162x minus 6x squared. And then, of course, we need to equate it to 0 and solve for x. Actually, we will get two values of x. Of course, this is not possible to have a dimension of 0, and we will only accept x equals 27. So if x is 27, we will be able to solve for y, and it says here it's also 27. So getting the volume of uh, the package or the box would be 19,683 cubic units. So that's how many Prada products they bought can be, put in this box. Okay, so let's move to difficult question number 3. Okay, let me scroll it up. So if you have any questions, or um if I didn't elaborate on some of the sections of solving, just let me know. Write it in our comment section, and I will answer it after this live session. Okay. So let's read D3. So the wood cutting machines at Agility Wood Inc. is programmed to cut a rectangular beam from cedar cylindrical log of radius 12 inches. So that's the radius of the log. First is that we need to show that the beam of maximal cross-section area is a square. Okay, so that's one. Second is 4 rectangular planks will be cut from the 4 section of the log that remain after cutting the square beam. Determine the dimensions of the planks that will have maximal cross-sectional area. And then number 3 is suppose that the strength of a rectangular beam is proportional to the product of its width and the square of its depth. Find the dimensions of the strongest beam that can be cut from the cylindrical log. So let's go answer question number 1. So this is how the log will look like. It will have a 12 inches radius here as shown in the drawing. So if we say this part here is x and this length here is y of that square part. So and we have this perfectly circular log. This means that the equation of this circle is x squared plus y squared. Square of 12 is 144, right? Square of 144. Okay, so the cross-sectional area of the rectangular beam is actually 2x. So this is 2x. And this is also 2y, right? So length times width, simply 2x times 2y. And then form let's eliminate y. So let's try to write y in terms of x. So this would be y squared 144 minus x squared. So y is square root 144 minus x squared, which is actually this part here. Right, yes, I did write it here. And we know that x would vary from 0 to 12, which is the radius of the circle. Okay, so again, let's take the derivative of a. We would get this. So product formula, right? So for x and then the derivative of everything in the square root, which is we need to bring down the power of it, which is 1/2. And then whatever is inside the square root, which is 144 minus x squared. So 1 minus 1/2, sorry, 1/2 minus 1 would be negative 1/2. That's why the exponent is negative 1/2. And then the derivative of negative x squared would be negative 2x here, right? So plus, so the derivative of 4x would be 4. and then just copy whatever is the square root, right? So the form 144 minus x squared is also equal to 144 minus x squared to the 1 half, right? Instead of using the quadratic symbol, we're using it as a fractional exponent. Okay, so by simplifying this, so that's algebra, and then we equate it to 0. So we equate it to 0. We will be able to solve for x. X should be square root of 72. So meaning the half of this is square root of 72. Okay, let me just, yep. Okay, so we got that. And then we need to solve for y. So substituting it in the equation here for y, we get again square root of 72. So meaning the value of x is equal to value of y. Therefore, we're already proven that the maximum area is a square, right? So even also if you try a area at 0 and area of 10, you would get a 0 still, right? And the rectangle or maximum area is a square. Okay. Okay, so for number 2, so using the diagram below to determine the dimension of the flanks that will have maximal cross-sectional area. So we already know that x and y is square root of 72, right? So the length would be, let's say this is x from here to here, and from here to here is y. So we're gonna solve for this, and this here. Okay. So let's move to the again. So the area should be 2x times y minus 72, right? And we already know the value of y, which is square root of 144 minus x squared. And we know that x would be between this value. So let's get the derivative again of our area. And we should be getting this. And then let's equate it to 0. And then solve for the value of x. So instead of doing a quadratic formula here, because we can use quadratic formula, I actually graphed it to see it easier. So you would have 4 values here. One is this, negative 10. Excuse me. And then next is negative 5. And then the third one is 5.088. And then the last x would be 10, right? So if you look at the boundaries for x, the only thing that would fit on this boundary is actually x at 5.088. What is, if you actually get square root of 72, that is, let me just compute it. So square root of 72 is actually equal to 8.48. So 10 is out of that boundary. So only 5.088 would fit in this equation. So we get, substitute that value, x of 1, and then we get 2.383 as the value of y, right? So therefore, each plank should have a dimension, of course, twice of our y at 10.176 inches by 2383 inches, right? Okay, so for the third question, we've given a relationship there that S should be equal to directly proportional to twice x and the square of the width, right? Which is 2y squared. So simply getting the square of 2y and multiplying all the variables, we would get 8kx. And then since we know already y, right, which is 144 minus x squared, so everything should be in in terms of variable x. So, and then getting the derivative of s in terms of with respect to x, and then equating to 0. So we have this, and then let's solve for x, and we get x as 4 square root of 3, or x equals square root of 48. So the next we need to do is, of course, to solve for y. So, and we get a value of y as 4 square root of 6. Okay? So we already solved the dimension at the maximum strength, which is, of course, 2 times 4 square root of 6, and 2 times 4 square root of 3, right? So that's why we have 8 square root of 3 here, and 8 square root of 6 inches. Okay, if you get that problem, you would get 4 points already. Okay, so now we're down to the last two problems. So if you have any questions, again, please write it down on our comment section below, and I will try to answer it after this live session. Okay, so let's go to difficult problem number 4. So again, this problem was given previously. So if you bought the ebook for Math Agility Competition 2020, you should be seeing this problem there in one of those more than 90 problems. The only thing I've changed this is some of the figure, but of course the process will be the same in answering this question. So let's read the problem. The states of Manchester and Birmingham is currently on the decision process in adding representatives to their respective states. The table below shows the number of representatives and population for the two states. Use the proper apportionment principle to determine which state the representative should be assigned if a new representative will be added. So we know that Manchester has this population, and currently they have 12 representatives, and then Birmingham has this population, and currently they have 14 representatives. So we need to compute the absolute unfairness of these two states. So let me scroll it up. So we will form this table. So the population of Manchester divided by the representative. If we add the representative there, that's why there's a plus 1 here. If we added the representative to Manchester, we would get 13. And the Manchester population per representative would be 46,134.8. So Birmingham, of course, would not get the representative. So the number of representatives would remain at 14. And this would be their data. So if we subtract whatever we got from this to 46,134.8 minus the 39,535.7 would be the absolute unfairness of apportionment. So that's one. I think that's part of what is required. Now, if we switch that Birmingham gets the new representative, so of course Manchester would remain at 12 representative, and we get 49,979.3. Now this time, since Birmingham will get representatives, that's why there's a plus 1 here. So 14 plus 1 is 15 representatives in total, and they would get 36,900. So the absolute unfairness of apportionment would be 49,979.3 minus 36,900, which is 13,079.3. Okay, so you get points when you solve this. What's the score for this? You should get 1 point. And then the next is to compute for the relative unfairness of the apportionment. So if Manchester receives the new representative, the relative unfairness of the apportionment is, so that's absolute unfairness of apportionment divided by the average constituency with new rep. So that's what is in the table. So 65991 divided by 46134.8, and we'll get 0.143 here. Same thing with Birmingham. So absolute unfairness is 13,079.3, which is this, right? Divided by the average continuancy, this one here, with new rep. So if you look at the table again, that's 36,900. This one here, not this one. Earlier, we used this and not this one as our denominator in the relative unfairness of apportionment. So let me scroll up again. So we will get 0.354. So because the smaller relative unfairness results from adding the representative to Manchester, so Manchester should have the new representative. So this is smaller, of course. So Manchester should get the representative. So that's the decision, right? And you would get how many points for the decision? 2 points. Okay. All right. So, but if you answered decision without computing those, I might give you a lower points for that. Okay. Or maybe no points at all because there's no basis of your decision. There's no computation involved. Okay. So let's go to the last problem. So we have difficult question number 5. Again, this is trigonometry, and we need to prove this identity. Cosine alpha of 2 times cosine alpha of 4 times cosine alpha of 8 times cosine alpha of 16 times cosine alpha over 32 is equal to sine alpha divided by 32 sine of alpha over 32. And we are asked to generalize the result. So again, from our identity, we know that the double angle formula is equal to this, right? 2 sine alpha times cosine alpha. So let's try to substitute the arguments. So these are our angle, alpha 2 over 2, alpha over 4, over 8, over 16, and over 32. So when we substitute this in this identity, and we should form cosine alpha is sine 2 alpha over 2 sine alpha. So when you substitute each of this argument, so cosine alpha over 2, you would get this for alpha over 2. This one for alpha over 4, alpha over 8, alpha over 16, and alpha over 32. All right. So when we try to multiply all of these cosine values that we got, so let's go to the next page. And of course, we have to also do it on the right-hand side. Oops, cancel. Of the equation. So we would see that there would be cancellation that will be happening. So the first is the sine alpha over 2 cancels out here. And then the alpha over 4, the alpha over 8, and the alpha over 16. So the result, only sine alpha would be left, and the last denominator would be the 2 sine alpha over 32, right? So if you noticed, uh, if you multiply 2 times 2 times 2 times 2 times 2, that's 2 to the 5th. And actually 2 to the 5th is also equal to 32, right? So we can generalize that this fractional part of the argument can be expressed in 2 to the n. So if you could continue the cosine alpha up to the 2 to the n, since this is 2 to, this is a factor of 2 with increasing exponent. So this means 2 to the n here at the end. So you could say 2 to the 6, 2 to the 7, 2 to the 8. So whatever your n is. And you would still get this result here. So sine alpha over 2 to the n, sine of alpha 2 to the n. So you can actually compare. So whatever is the last part of your cosine alpha here would be based on the 2 to the n part in front and the denominator of your argument. All right. So we're done. So if you have any question, again, please write it down on our comment section. Um, and once again, let me congratulate the semifinalists, Gerald Adorna, Joshua Emmanuel Hugo, Mansur Aguas, Clarence Turan, Eugene Rosete, John Reynan Bornelia, and Kyle Sherwin Balala. Congratulations. And if you didn't make it, you can still join or register for the elimination rounds 2, 3, and 4. And make sure you review the old questions we given last year, 2020. So let me stop sharing my screen. Okay, thank you for watching us today at Math Agility Live. To all our followers who sent in their questions from Thursday to Sunday, Friday to Monday in Manila, we will be solving them via Facebook Live next Tuesday PST, that is Wednesday in Manila. So see you next Tuesday. God bless everyone and stay safe.